Hi, just to give you some information about the lesson you missed. So first you obviously need to do the warm-up. You want to go to the summary slide on slide 19 if you haven't yet, and fill out the row for volcanic eruptions. All right, so you'll think about like, describe the process, how long did it take? Is it fast or slow? Keeping in mind that slow in geological terms is like millions of years. And then how big of an area does it affect? And then make sure you click update on slides 23 to 26, and slide 23 is the warm-up. Okay, pause here and do that. Now when you're done, today we're talking about the process of weathering, because you probably thought about, you may have remembered that from learning it before when you were doing the warm-up about how igneous rocks can break down. You might have said erosion, but that's actually how broken bits of rock move. Weathering is the process of rocks breaking down. There were 3 lab stations that showed examples of physical or chemical weathering. So there's chemical weathering with putting acid on a rock, because acids occur naturally in nature, whether produced by plants or by mixing with certain molecules. Mixing with water can make the water acidic, and even water itself can react with certain minerals in rocks. All right, then there's physical weathering by abrasion, which is rubbing or scraping, and physical weathering by frost wedging. You'll see all of these. And so for each step, you'll need to describe your experimental process and your observations. This is graded for conducting investigations. All right, so when you're done with the experiments, you'll need to go to slide 25 and watch the video and take notes about physical and chemical weathering. All right, and then draw a model for slide 26 that shows physical and chemical weathering, and then update the weathering row on slide 19. All right, so we're gonna talk about some weathering investigations. This first one is chemical weathering. What we have here in this beaker is some vinegar, which is a weak acid. It's stronger than acids that occur naturally in nature generally, but it'll give us a sped up process of what happens when acids affect rocks. So here's a rock. It is a real rock, but if you look, this rock is actually made of bits of sediment and shells and things like that. So this is a type of sedimentary rock. So if we put it into the beaker of acid, you can see that it immediately starts fizzing and bubbling as the minerals react with the acid. And if you look closely, you can even start to see that the liquid is getting cloudier, because bits and pieces are breaking off of the rock. So you can even see some of them at the bottom of the beaker. So like little bits of sediment have already started to break off. Okay, so this is chemical weathering. And the longer we wait, the dirtier the vinegar is going to get, because more and more sediments and bits of shell and things like that are going to break off of the rock. We'll wait 30 more seconds. You can see it getting cloudier as little bits of sand and sediment come off of the rock. So this is a super sped up version of what we would see happen in nature in chemical weathering. Yeah, so you can see that this is much cloudier than it was. There are little bits of sand and sediment at the bottom of the beaker, floating around in the beaker. That's why the liquid is yellowish now. Okay, here is the same beaker, but with the rock having been in about 15 minutes, and you can see how much more sediments have broken off. There's some floating around, there's a lot on the bottom. So there's real evidence of chemical weathering, bits of rock broken off by the chemical reactions. Our next experiment, so that was station 1. Our next experiment is physical weathering by abrasion. This can happen when wind blows sand and rocks or in the water. All right, and so what we have here is 2 pieces of chalk. Chalk is actual natural mineral made during the rock cycle. And so there'll be even like the White Cliffs of Dover, if you've ever heard of that, is in England. And they're just these huge cliffs that are made entirely of chalk. Okay, this is obviously colored, but that'll help us see the physical weathering better. All right, so we have in this bag some salt that's standing in for sand, and we're going to see what happens if we rub the chalk with the salt. So here is the salt. I'm gonna put the chalk inside so this can simulate like wind blowing at the chalk, and I'm gonna rub, or the rock tumbling along in a stream, or the rock sitting at the beach and getting hit by waves and sand. And we can already start to see that it's turning pinkish. So bits and pieces of the rock, of the chalk, are breaking off due to the abrasion or rubbing, I should have sealed that bag, by the salt. So it's getting darker. Look at how dark it's gotten. We'll erode just for a little bit longer. Okay, so now we're going to compare it, and I have a control that wasn't eroded. So if we look at these two, the control still has this edge here, and this has been rubbed off on this rock. The control is also really smooth, whereas this one has little bumps and texture from being eroded. All right, so physical erosion by abrasion means that lots of bits and pieces break off of the rock as it's hit and rubbed with things. Final example is physical weathering by frost wedging. So this is a rock that we made out of plaster, okay, to simulate a real rock. Obviously, frost wedging takes a lot longer. So we've sped up the process by making the rock so that we can see what happens. So we made the rock and we put some water inside of it. Now, normally water naturally soaks down into rocks, but this was our simulation. And then we put the rock in the freezer. And as you can see, here is the evidence of frost wedging right here. The rock has a big, huge crack right through the center of it. Okay, so this happens because unlike all the other molecules, we know that normally when things lose heat energy, when they cool down, the molecules come closer together, they move more slowly, but water is an exception. It makes this kind of crystalline structure when it freezes, and so it actually slightly expands. And so that means when the water soaks down into the rocks and then gets colder and freezes, the rocks start to crack open, and so you could end up eventually with this breaking into 2 separate rocks. You could get little chunks breaking off. But yeah, you can end up with frost wedging just splitting a rock in half. This also affects pavement and roads and things like that. And so they call them frost heaves if you live somewhere where it's cold, like in America or Canada, where the road ends up with these big cracks and bumps on it because water seeped in and then froze. So that is frost wedging, which is another type of physical weathering. So for each station, you want to make sure you have recorded a procedure, like what someone did to set up that experiment or to do the experiment, and then your detailed observations. And then when you're done with that, there's the next 2 slides. One has a video where you take some notes about weathering, chemical weathering and physical weathering. And then the last slide, you draw a model that represents one type of physical weathering and one type of chemical weathering. All right, and that's what you need to do. Have a great day.